Hi guys. Alright, so we are going to do investigation 2.3 today. So as I'm talking, please be opening your books to 2.3. I'm actually out of town right now, which is why I'm recording this. I just realized that I'll be at a cross-country meet tomorrow on Wednesday, so I needed to have some plans for you, and I didn't want to keep having to do more packets, so we're going to go on and do investigation 2.3. As you watch this video, it might be helpful to have one of you guys sit near the screen. I know probably all of you are volunteering to do that right now. So have someone sit near the smartboard and then you can click pause whenever you guys need a break to try something. There'll be some parts in the video where I actually tell you to pause it. So have someone sit there and be ready and use as much time as you need to. The video itself won't take the whole class, but with the pauses it might take some time. So the things you need to do right now are you need to be in investigation 2.3, and I actually don't have my book with me, so I'm not sure which page it's on, but I'm sure you guys can find it and someone can tell everyone what page it is. And you just need out lined paper. You do not have to use graph paper for this. You can if you want. You can use graph paper if you want to, but you won't need graph paper. So we're in investigation 2.3. It's called Treetop Fun, Equations for Linear Functions. You can see right here there's a little intro video, so remind me when I get back on Thursday and we'll watch the video together. So it says Treetop Fun, which they're going to call TTF for short, runs adventure sites with zip lines, swings, rope ladders, bridges, and trapezes. The company uses mathematical models, hey, that's the name of our book, to relate the number of customers, prices, costs, income, and profit at its many locations. Now, when I'm back tomorrow, we'll talk about the difference between things like prices, costs, their income, and their profit, especially the difference between income and profit. So just kind of keep that in mind as you go if you kind of already have something to say for that, because there are some important things that we want to point out about that difference between a company's income and its profit. So we're going to start 2.3a here. You can get A ready on your paper. It says when finding an equation, it may be helpful to calculate values of the dependent variable for some specific values of the independent variable. Then you can look for a pattern in those calculations. You can use the information given in words, tables of data, and graphs. So those are the three ways you're going to get information today. You might get it in words, I might give you a table, or you might get a graph, and you're going to have to use one of those three things to write an equation. So here's part A. It says use what you know about linear equations to work out models for the Treetop Fun business. Find an equation for each of the linear functions described below. So for all of these on part A, you're going to be writing an equation down. So on A1, it says the standard charge per customer at Treetop Fun is $25. Write an equation that relates the daily income I to the number N of customers. So what they mean when they say that income I, and number N of customers, those are the letters they want you to use. They want you to use the letter I, a capital I for income, and they want you to use a N, a lowercase n for customers. So I want you guys to, as soon as I finish the sentence here, pause this video and see if you can write an equation for how income can be calculated if they earn $25 per customer. And each customer, the number of customers we're going to show with the letter N. So go ahead and pause the video. Take about, you really only need maybe 20 seconds. Write an equation, and then we're going to come back and I'm going to go over this one with you. Alright, hopefully you had some time to write an equation. I want to go ahead on this one. I'm not going to do this for every single problem, but we're going to check your answer here. So here, we're trying to show how to calculate the income. So we want to show what their income is equal to. So hopefully you have I equals, now this is going to be a really short equation. We just know that they get $25 per customer. Whenever you see that word per, it kind of means multiply in your equation, because they get $25 if it's one customer, they get $50 if it's two customers, they get $75 if it's three customers. So we're always multiplying 25 times the number of customers. So we want to write for our equation I equals 25 times n. You could also just write I equals 25n without that little dot in there, but I'm trying to write on my computer and it's really hard here. So hopefully that is what you got for your equation. If not, it's okay, you will catch on soon. So we're going to go on to A2 and A3 right now. Alright, so on A2, we're going to be doing the same thing. We're going to work out a model or an equation for this description below. So A2 says each treetop fun site has operating costs of $500 per day. Write an equation that relates the daily profit to the number n of customers. Okay, so in this one, I want you to think about the fact that they're still making that $25 per customer. But now they also have this cost of $500 per day. So hopefully when you were thinking about the difference between income and profit, we thought about the fact that income is just what's coming in. Profit also takes into account what's going out. So now I want you to use that equation you wrote, but I want you to also take into account the fact that they have this cost of $500 per day. So go ahead and pause the video and try to write a new equation that shows their profit P related to the number n of customers. Alright, so hopefully you had some time to do that. This is a tricky one. I remember doing this with my students last year. So we want to show how to get profit. So we want P equals, usually the first thing they tell you, relate the daily profit to the number of customers. Well, profit depends on how many customers are coming. You want your dependent variable all by itself here. So profit equals, well, we're still getting $25 per customer, right? So we're still getting that 25n. But now we have to take into account that we have to spend $500 a day to run this park. So from the $25 we get from each person a day, we have to subtract $500. Ooh, this is tough to write. So this should say P equals 25n minus 500. This is the solution that you want to get on this problem. Now, one common mistake I saw last year, I'm going to do it in red here, is that people put an n with the 500 as well, but that would mean that they lose $500 for every customer that comes. Well, that would be really bad because they only make $25 per customer. So make sure you don't put an n next to the 500 because we're not losing that for every customer. We only have to spend $500 once. All right, let's go on to A3. It says one treetop fun site brought a new rope bridge for $4,500. Treetop Fun will make monthly payments of $350 until the bill is paid. Write an equation for the unpaid balance, B, after M monthly payments. So you're going to write an equation that shows their balance, you're going to represent with the capital B, after M monthly payments. Okay, so their balance is how much money do they still owe. Okay, so in this one, you can kind of forget about the $25 per customer and the $500 a day. We just want to show, they have to make these payments to a bank or something for this rope bridge. I want you to think about how much is their balance in the beginning, and then how does that balance change every month. So go ahead and pause the video and try to write an equation there for me. Alright, so the equation we should have gotten here is that their balance is equal to, well, it starts at $4,500, and starts is kind of an important word when we're talking about these equations because we want to have that in there. A lot of times that's our y-intercept. It's the number all by itself. So our balance starts at $4,500, but every month our balance with the bank goes down a little bit. So every month we get to take away $350 from our balance because we're paying that off. Now we don't just take away the $350 once, we take it away every month. So we want to multiply that 350 by M, and M represents the number of months. So if 2 months went by, we would put a 2 there. If 3 months went by, we would put a 3 there. So our balance, B, is equal to 4,500 minus 350M. So now we're going to go on to complete the rest of this investigation. I'm not going to go over each one with you anymore, but I am going to introduce each one for you. So we're going to go on to question B1 now. So on question B1, it says, one operator of a Treetop Fun franchise suggested the group admission fees in the table below. So what I want you guys to do is answer this question here. You're going to look at this table. You don't have to copy it down, but you need to use complete sentences here. I want to know, how do you know the relationship between the admission fee, here's the admission fee, and the number of people in the top is a linear relationship? Okay, so tell me how that is a linear relationship. You don't have to pause it yet. I'm going to go on and explain the rest of B so that you guys have some time to work on it. If you finish B before we go on to question C in this video, you can go on to question C. That's fine. I don't want you bored and waiting. The only thing I ask is that whenever the video starts up again, I want you to pay attention just to make sure you're understanding the questions. So on B1, I want you to explain how you know this is a linear function. It would be great if you use the word rate of change. On B2, they want to know, it's the same table, I believe. I want to know what's the slope. So think about the change in y and the change in x and how you can relate those. Here's your y. Here's your x. It's really hard to write. That's an x. Oh, I made it worse. Oh well. This numbering group is x, admission is y. I want to know what's the slope and what's the y-intercept. You might have to do a little work to find the y-intercept. And then on B3, I want you to write an equation that relates the admission fee A to the number n in the group. So on B3, usually when we write an equation, we plug our slope and our y-intercept in to y equals mx plus b. So now we're just changing the y and the x to fit our situation a little better. So now we're going to be writing A equals m times n plus b. So just like usual, you guys are just going to switch out the m and the b with whatever your slope and your y-intercept are. So keep that in mind as you work on this one. So go ahead and pause it. Take some time to work on part B. I would say you guys need about 5 minutes to do this, and then we'll move on to question C. Alright, question C is giving you a graph. It says the owners of Treetop Adventures opened a snack bar at one site. The graph below shows the income from snack sales for different days. What is the equation of the linear model on the graph? So remember, linear model means the line. So what I want you guys to do on question C is to look at this line. You're going to need to find the slope, and you're going to need to find the y-intercept. And I want you guys to write the equation for that line. When you find the slope, be really careful of what these scales are going by. They're not going by ones, and they're going by different amounts. So when you find your rise and your run, be really, really careful, okay? Go ahead and pause this, and you probably need just about 3 minutes to work on this part C. Alright, we're getting there. We're on part D. So for part D, you're going to tell me how you would go about writing equations for these different situations. So it says, suppose you were asked to write an equation of the form y equals mx plus b to represent a linear function. What is your strategy for each situation? So for D1, it says you're just given a description of the function in words. Now this is just like on part A, where they gave us a description like, well, they have to spend $500 a day, but they make $25 per customer. So I want you to describe to me in complete sentences, how do you pull the information from those words to plug it into your equation? What do you listen for in the description to know what's your y-intercept and what's your rate of change? Describe to me how you would listen for those things to write an equation. On D2, it says you're giving 2 or more x or y values or a table of x and y values. So if I give you a table of several points, how do you find an equation? So I want you to describe to me in complete sentences, if you have a table, how do you find the slope and how do you find the y-intercept? And then on question D3, it says you are given a graph showing points with coordinates. So if you're given a graph, hopefully your first step on this is to draw your line of best fit, draw a model, and then tell me from that line, how do you find your slope and how do you find your y-intercept? Be really specific for me. Okay, this question you guys might need a while. If you have time, I want you to go ahead and take about 10 minutes to answer this question D. Okay, so pause the video and do that before we move on to E. Alright, question E. This is a little bit of a challenge. It says a state mathematics test asked students to find equations for linear function. Two students, Dana and Chris, gave the answers below. So here's the first one. To find an equation for a line with the slope of -3, so I'm going to write over to the side, m equals -3. I know this is really hard to read because I did it in yellow for some reason. And it passes through the point 4, 3. So we know m is -3, and we know it passes through this point 4, 3. It says, here's what Dana did. Okay, and it says, is he correct? Explain. So he said y equals -3x plus b. So think about that step. Think about where did he get that -3 from? Did he put it in the right spot? Then he says, so 3 equals -3 times 4 plus b. So what I want to point out here, we haven't really talked about this yet. Where he got these numbers from is he has this point, x is 4 and y is 3. So he knows that if he plugs in 4 for x, which he did right there, that he should get out a 3 for y. So he put a 3 in the place of y. So he replaced the x and the y in his equation with the x and a y coordinate that he knows. He has the slope in there still, where he should. The only thing he doesn't know is what b is. And I want to tell you guys, this is a good thing to do. This is okay that Dana did this. This is a good strategy. We haven't talked about it in class yet, but you can do this. You can put in an x and a y that you know. So he says this means that b is 15. So I want you to think about, does the number 15 fit right here? Think about what -3 times 4 is, and think about if you added 15 to it, would you end up with a 3? So I want you to tell me, is Dana correct in this? This is a tough question, so we will go over this tomorrow, but I want you guys to try it. And then finally we have question E2 here, and this is Chris's strategy. So Chris had to write an equation for a line that goes through 4, 5, and 6, 9. So I want you guys to look at this and see if the slope that Chris got here, 1/2, is that the slope that you guys would get from these points? So remember that these points, 4, 5, and 6, 9, you can write them, whoa, I don't know why I made that y so big. You can write them in a table. So we've got 2 points, 4, 5. So 4 is x and 5 is y. And 6, 9. So we have another point here when x is 6, y is 9. I want you guys to find your slope from this table, see if you get the same thing as Chris. And then I want you to follow through the rest of Chris's work here and see if you agree that that is a correct solution. Alright, so when you finish this, if you guys have extra time left, you can begin working on your homework. Again, I don't have the book, so I'm not sure which page it is, but I'm going to write your homework on the board. So it should be written on the chalkboard, and I believe I'm doing problem 21 with you. Actually, I can check right here, but I still don't have the page number with me. But it's when you go to those ACE problems right after the investigation 2, you're going to go find problem 21. So, whoop, I passed it up. Problem 21. I think this is the right one. Yeah, this is the right one. It's about Anchi and Jonah. So, yeah, interesting name here. So I want you guys to do this problem number 21 for homework. It is due tomorrow. And you do not have to do this on graph paper. There is a graph, but they give you the graph. So you can do this on regular lined paper. Alright, hope this video works out, and I will